Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study some of the problems, how to solve them. The problems related to the total elongation or extension or deformation of the bar under various loads, such as tensile load, compressive loads. Now here, let us recapitulate. It is the tensile test results related to the specimen name is mild steel, and the diameter of the specimen is 40 millimeters and it is 200 millimeter long. It is subjected to a load of 40 kilonewtons. So here delta L, change in deformation, is 0.0304 millimeter, and yield load, maximum load are 161 kilonewtons and 242 kilonewtons. The length of the specimen at fracture is 249. Originally it is 200 millimeters length. After deformation it is 249. That is 49 millimeters increased. Now here there are four objectives: modulus of elasticity, yield point stress, ultimate tensile stress, and percentage of elongation. This ultimate load or ultimate stress comes when it is a maximum load condition. This ultimate stress can be calculated. Now here ultimate stress equal to maximum load by maximum load upon area of cross section. The area of cross section remains the same throughout the test, that is 40 millimeters diameter. Area of cross section A equal to pi by 4 times d square. That is pi by 4 times, what is the d here? The diameter is 40 millimeters square. So thus we will calculate the area of cross section under these loads. Similarly, yield point can be calculated. That means yield point stress equal to yield load by yield point load over area. Yield load is 161 kilonewtons. Thus we can calculate this modulus of elasticity, that is stress by strain. The stress equal to load per area and strain equal to change in length by original length. So these four objectives can be calculated by using this formula. And percentage of elongation, finally percentage of elongation means length of the specimen at fracture minus original length upon original length. So length of specimen at fracture is 249, that is millimeters, and actual length of the specimen is 200 millimeters by 200 millimeters. So this is the 24.5%, that is the percentage of elongation. If the percentage of elongation depends upon the percentage of elongation, the value of the percentage of the elongation, we can determine whether the length the deformation has taken place more or less. If the percentage of elongation value is high, that means the deformation is high. If the percentage of elongation, the value of the low is low, that means the deformation is low under the same load. So based on this value of the percentage of elongation, one can estimate, one can predict the behavior of the material under the tensile load during tensile test. So this is the problem here. How to find out the total extension under the tensile load of 15 kilonewtons. Here 15 kilonewtons tensile load it is acting. It's a variable cross section problem. How to find out the total length, that is delta L, that is the total extension. Here total extension means it is under tensile load. Delta L equal to the cross section 1, 2, 3. That is the delta L of section 1, delta L1 plus delta L of section 2, delta L2, and delta L of section 3, delta L3. So what is the delta L? That is the delta L, we know that P1 L1 by A1 E1. What is delta L2? P2 L2 by A2 E2. Delta L3, P3 L3 by A3 E3. Here the material remains the same. The material is steel. It is made of steel. All the three sections made of the same metal, same material. So that is E1 equal to E2 equal to E3, that equal to E, that is the steel. So, and one more thing, the load acted on 3 cross sections is remains same. The load acted is 15 kilonewtons. That is P is remains same and E is same. Then L1 by A1 plus L2 by A2 plus L3 by A3. So here L1 by A1 and L2 by A2 and L3 by A3. What is A1? Area of cross section 1. The area of cross section based on the given dimensions, one can understand it is a circular cross section. That is middle portion is 15 millimeters and two ends are 40 millimeter and 30 millimeter in diameter. That means the cross section area of cross sections are the area of cross section is the circular cross section. So pi by 4 times d square. So after calculating areas, substitute over here A1, A2, A3, and the L1 is 200 millimeters, L2 500 and L3 is 200 millimeters. So this L1, L2, L3, A1, A2, A3 and P that is 15 kilonewtons, E modulus of elasticity that is 200 giganewton per meter square, convert into Newton per meter square, that's 200 times 10 power 9 Newton per square meter. After substituting those values, we can observe the total extension. The methodology is this: the total extension is measured as 0.2454 millimeters. This is the formulas we substituted. This is the recapitulation. Let us begin next problem. Yeah, this is very important model. The cross section is remains same, but the loads are varying. Suppose there is LM portion, MN portion and NP portion. Let us read a problem. What to find out, what to be found, what are the input parameters were given here. A brass bar is having cross-sectional area of 1000 square millimeter. A equal to 1000 square millimeter. Is subjected to axial load, is subjected to axial forces. These are the axial forces. These are the axial forces. The axial forces 20 kilonewtons, 50 kilonewtons, 80 kilonewtons, 20 and 10 kilonewtons. Find the total elongation of the bar. What is the total elongation of the bar? Modulus of elasticity of the brass. Here it is made of brass. It is a brass bar. That's why the brass. That modulus of elasticity is 100 times 10 power 9 Newton per square meter. So this is the data given here. Now total extension, that is delta L equal to, we have to know it, delta L of section 1, that is LM, plus sum of this algebraic, that is delta L of MN section and delta L of NP section. So before going to before going to start the problem, what to do? We have to draw the free body diagram by individual sections. LM section, MN section and NP section. So the sections are here. This is LM. Another section, it is, we don't know the direction of the force here. It is MN. And the section of another section is NP. We have to find out, here it is 50 kilonewtons acting and here it is 10 kilonewtons. We have to know what are the forces are acting on this. This is the unknown force which is acting on this, which is tensile direction. So algebraic sum of this M portion we want. So make it, so towards the tensile is positive, compression is negative. Then what will happen? 50 plus, now this portion we want. So this portion if we want, in this section we make it. 80 is a tensile, 80 minus that X force X equal to 80 kilonewtons minus 20 minus 10. 80 minus 30, that is 50 kilonewtons is acting here. This is the force of 50. If it is 50, okay, how much load is acting now on this? 80 minus 50 here. Here 50 is acting now individually. This is the 15 direction. Now 50 is the tensile. What is the compressive force? The compressive force which is acting here. What is the total compressive force? The compressive force which is acting on this section is 20 plus 10, 30 kilonewtons. So 80 in this direction, 80 already 50 is a tensile. 80 is compressive, 50 is in tensile. 80 minus 50, 30. It is a compressive. Now it is a 10. 30 is towards left direction, and whatever to 10 here, it is also, now it is the tensile. 30 is compressive and 20 is a tensile. So 30 minus 20, 10 becomes compressive. Now if you validate whether it is right or wrong values, if the 50 okay, then join this section. If you join the section, this is 50 kilonewtons. If you join the section, 50 plus how much? 30 is acting in this direction. That is 50 plus 30, 80. Now in this section. Next, if you join this side portion, 10th portion, 30 in this direction, 10 opposite. 30 minus 10, 20. Then, what is the last section is? That is the 10 kilonewtons. So, whatever we resolved here, it is same. Now we got it. It is 50. 50 is pulling that direction. So, what is this force again? Let us calculate. What is the force acting here? That means 80 towards right, 20 and 10 towards left. So 80 minus 20 minus 10, that is a 50, that towards right direction. That is the portion if you make it. Next, if you want this portion, if you want from this direction, suppose this portion if you want, suppose if you make it y. So what will happen? 80 this direction, 80 minus this portion if you want on this body. What is the force which is acting here? 80 in this direction towards right, 50 and 10 if you consider this portion. 50, 80 minus 70, 10. That's why we got here 10. Now if we want this portion exact on this body, what is the load is acting on this body? This body we want a middle portion, Mn portion. This 10 already acting on this, 10 plus 20 plus 10, 30 is acting towards the compression. Alright. In that manner, we can find out, and we can find out unknown forces. This is called equilibrium. Now, the complete body is in equilibrium. We have drawn the free body diagrams. Now, Lm portion is section 1, Mn portion is section 2, and NP portion is section 3. The load, total extension of the bar, that is delta L equal to, how to calculate? Delta L equal to delta L1 is tensile, positive. Delta L2 is compression, that is negative deformation, that is called decrement takes place. In L1 tensile load, increment, deformation. In section 2 it is a decrement. And again section 3 is compression, delta L3. What is the delta L1? P1 L1 by A1 E, because E is the same material. The brass throughout minus P2 L2 by A2 E minus P3 L3 by A3E. Now here, what is the P1 for section 1? 50 kilonewtons. What is the P2? 30 kilonewtons. What is P3? 10 kilonewtons. It is same cross section but variable load. Now what is the cross section here? The cross section mentioned here, that the uniform cross section, that is 1000. That means A1 equal to A2 equal to A. Alright. That is, what is the common here? The common from this equation is, what is the common from this equation? Delta L equal to 1 by AE times P1 L1 minus P2 L2 minus P3 L3. Okay, cross section given. And what is the P1? 50 kilonewtons. What is L1? 0.6 meters. P2 30 kilonewtons. L2 1 meter. P3 10 kilonewtons. L3 is 1.2 meters. If you substitute back here, then we can get it. The total extension or total elongation of the bar. Let us see the solution. Yeah, these are the solutions. You can see it. Here it is 50 kilonewtons. How we calculated 50 kilonewtons? So the loading of the three different portions, LM, Mn and Np, is shown. Three different portions, LM, Mn and Np. LM, Mn and Np. These are the three different portions. Now portion LM is under tensile force of 50 kilonewtons to the left side, and to the right of it there is again an effective force 50 kilonewtons, which is a resultant of the three forces to its right. How to get it? So this is what is right side force, 80 minus 10. In this, the right side force want 80 tensile minus 20 minus 10. So this is 50 kilonewtons. This portion we got it. Thus, if we apply it, simplification. Now, that is for LM portion. We got it 50 and 50. Next, coming to Mn portion. In Mn portion, the compressive force on the left is how much? The compressive force on the left is 30 kilonewtons. That is, how we got it? 30 kilonewtons. We already know 50 here, 50 tensile, 80 compressive. 80 minus 50, that means 80, that is 30 kilonewtons compressive. That is 30 compressive. Okay, 30 become compressive. Now on the right side, that is how much right side? We have to add the sum of 20 plus 10. That is 30 and 30 under compressive. That is for Mn portion. The next portion is NP portion. In this NP portion, already compressive load how much? 10 kilonewtons one side on the right side. But towards on the left side of NP portion, how we will get it? 80 we want on this. So we consider all the three forces. 80 is compressive, 80 minus 20 minus 50. That is 10 kilonewtons finally, that is 80 minus and to the right side. So there is already compressive load of 10 kilonewtons. So we observe that the bar is equilibrium. That the bar is equilibrium under the action of these forces. This is delta L1. We want sum of. So delta L1 is the applying. What is the section 1? The section 1 is LM portion. Yes, section 2 is considering, section 2 Mn portion is considered second section, and NP portion is considered as section 3. So here the section 1 is under tensile load, there is deformation. Section 2 is under compressive load, there is a decrement in length. No deformation, there is a decrease in length. Next, third section 3 is under compressive load. So again it is decreases in deformation. So delta L1 section 1 increases, delta L2 decrease, delta L3 decreases. So increased portion is considered as a positive, decreased portion is considered as a negative. So the decreased portion, that is delta L1, P1 L1 by A1 U1, P2 L2 by A2 E2, P3 L3 by A3 E3. Here, why P1 L1 by A1 U1? Why here area of cross section is same and the material is same throughout the cross section. So that's why P delta L1 equal to P1 L1 by AE. Delta L2 equal to P2 L2 by AE. Delta L3 equal to P3 L3 by AE. So these are the things after substitution. Why it is negative? Because it is decreasing. Delta L1 is increasing, positive. Delta L2 decreasing, negative. Delta L3 also decreasing, negative. So substitute over here all the values, then you get it minus negative 0.12 millimeters. That means it is shortened. There is no deformation, elongation. It is negative sign means it is shortened by 0.12 millimeters. Under the application of this load for a cross section of 1000 square millimeters area of cross section, when the loads are applied here 50 kilonewtons, 80, 20 and 10 for the length of 0.6 meters, 1 meter and 1.2 meters for a material of brass having a modulus of elasticity of 100 giganewton per square meter. Okay, this is the problem. In that manner, we have to solve the total elongation of the bar. Now the next problem, if you want to, we can interpret more. Suppose if the cross section of the bar there is how to draw the free body diagrams. If the cross section of bar here, it is 40 kilonewtons, in this 70 kilonewtons, here it is 20 kilonewtons. Then the value of this is 40 plus 20, 16. It is 10 kilonewtons. So if we consider this LM portion, L, M and P. So how to draw the free body diagram? So to maintain the equilibrium, whether we have to see the body should be in equilibrium, is a section 1, section 2 and section 3. Consider the LM portion and it is LM portion, it is MN and it is NP. So here the free body diagrams are very important in order to find out the loads, what type of load which is are acting on the sections 1, 2 and 3. So then only we can, the total elongation, whether we can understand the section 1 is under compressive or tensile, or section 1 is tensile or compressive and section 3 is compressive or tensile, we can understand it. Now here it is already acting 40 kilonewtons tensile. Now we want the portion at on the M side, the L side 40 kilonewtons tensile. Here L side, now we want this side. What is the value? This portion. Already 40 is acting. Now this portion comes. How this side portion comes? Let us 70 minus, what is the total load it is acting here? 70 is going towards left. 70 minus 20 minus 10. That is means 40. 70 minus 30. That is 40 kilonewtons tensile. Okay. Now we want this portion. So 70 already there. Now you consider this relation value with this value. 70 is compressive on M section, but 40 kilonewtons acting tensile. Now 70 minus 40, 30. This is the 30 kilonewtons compression. We want N side. N side means this edge on MN body. 20 plus 10, 30 kilonewtons compressive. Okay. Now it is already P side is 10 kilonewtons. Now it is 20 compression. Okay. Then what will happen? 30 minus, it is a tensile on the body 3, compressive on the body 2, on the section 2. So 30 is a compression here. 30 minus 20, 10. 10 becomes compression. So if we combine these portions, all these portions, the net figure has to come. This figure has to obtain. How it comes here, if you join clearly, I am joining L, this is the L portion. L portion, that L is 40 kilonewtons. Now M, if you want to join, there are two values here, 40 and it is 30 here. Both are in the same direction if you consider it. 40 plus 30, how much? 70. In the direction of, yes, in this direction, 70. Next, this is M portion is over. Next, N. Here N, both sides are 30 and here 10. The 30 and 10 both are in opposite direction, not in the same direction. So 30 minus 10, 20. This 20 is a maximum force, 20. Join it. Now, this is P side, it is 10. In that manner, you can validate whether your direction of the forces are right or wrong. Now here you can see this is section 1, it is section 2 and it is section 3. Suppose area of cross section is same, is uniform area of cross section and modulus of velocity value is the same for all, section is same, it's the same material. Then what is the total elongation? Delta L1 is what? Tensile. It is a tensile. So what will happen? Tensile load is acting. So it increases the deformation, increases positive. Delta L2, compressive load, it is a decrease. So negative. Delta L3 is again compressive load on delta L3. Delta L3 is acted by compressive load. So again decrease is negative value. So what is the total elongation? The total elongation delta L equal to, the total elongation delta L equal to, delta L1 is positive, delta L2 is negative and delta L3 is negative. What is delta L1? P1 L1 by A1 E1. Delta L2 P2 L2 by A2 E2. Delta L3 P3 L3 by A3 E3. Now here it is the same material and same area of cross section throughout the sections. So 1 by AE times P1 L1 minus P2 L2 minus P3 L3. This is the modified formula for this data and for this case study, for this case. Suppose if L1 is same uniform cross section, if L1 equal to L2 equal to L3, both the three are equal, then this formula can be modified as L by AE times P1 minus P2 minus P3. So here the important thing in this problem, in this type of problems are you have to draw the free body diagram, whether it is to maintain the equilibrium. Now 40 kilonewtons for section 1, left side and right side equal, it is in equilibrium, equal forces in equilibrium. If it is not equal, it will not be in equilibrium, we can't apply. So the body should be in equilibrium. Now here again section 2, 30 kilonewtons equal, compression. Equal and opposite forces are acting, it will be in equilibrium. Similarly section 3, if we consider it, again equal forces are acting, 10 kilonewtons, it is under compression. So under compression load, there is decrease in length. Under tensile load, increase in length, that is deformation takes place. Under compression load, what will happen here? There is a decrement in length. Now here, section 1. By considering the diagram, this diagram, you can see what are the forces are acting. The compressive load is acting, we can't define it, what are the exact values, unless and until we draw the free body diagram. After drawing the free body diagram, we can know what are the forces are acting, what are the forces and what are the value of the forces are acting on section 2. Otherwise, the section 2 here 70 and 20. But after drawing the free body diagram, it is not 70-20, it is 30 kilonewtons is acting on that. So after here 10 kilonewtons compression, here 40 kilonewtons tensile. But whatever middle portion, what the middle section is this compressive load, what is the value of that load? that can be known only by drawing the free body diagram. Again, let me explain this free body diagram, how to draw. Step 1. First, draw the individual sections LM, MN and NP. After drawing it, from this one end, the section 1, the tensile, that's 40 kilonewtons. So on the opposite side, what is the value it is acting? How to find out? You take the portion of this portion. You can know what are the value of the forces acting on that. 70 is towards right from my side, and 20 and 10 towards left. So 70 minus 20 minus 10. That value gives the value of the force acting on the M side. That is 70 minus 10 minus 70 minus 20 minus 10. That is 40 kilonewtons. Now we have to find out Mn section on the M. So how to correlate it? Now here you have to understand not in the same direction or not. It is you have to consider compression and tensile direction. Now here 70 kilonewtons are tensile. Now 70 kilonewtons are tensile with respect to M, body LM. But it is acting compression on Mn. So the compression is 70 kilonewtons. We are considering the force which is acting on section Mn. That's why our reference is with respect to Mn section. So this 70 kilonewtons is a compression Mn. And what about 40 kilonewtons? A tensile with respect to M. So 70 minus 40. 70 is the compression, 40 is the tensile. So 70 minus 40, that is 30. But maximum direction is compression. That's why 30 kilonewtons. Now it is 30 kilonewtons. How to get it on the section N acting? So on the section N, there are two forces acting here. Now you have to consider these two. That is 20 is acting on section N and also 10 also acting on that. So 10 plus 20, that is 30. Now coming to NP section. By coming to NP section, that 10 kilonewtons already compression one side. So what about another side? N side we want. So N side is shared by two things. N side is shared by here, N side, that is 20 kilo. We have to consider here 20 kilonewtons is towards which direction? Towards is acting, is the tensile. 20 kilonewtons is tensile with respect to N. But here 30 kilonewtons compression. So compression 30 minus 20 tensile. That is 10 compression. So like that we have to find out. How to, when we are junction, at the junction, we need what type of force are acting shared by. So junction M, when we are considering the force which is acting on the section 1 at M, we have to consider all the forces this side. Then it is acting. When you are coming to junction M on Mn section, then you have to consider the junction force N, that is 70 kilonewtons compression and 40 kilonewtons tension. So 70 minus 40, 30 kilonewtons. The maximum force is in compression side. That's why compression. Now coming to N section. Here what is the force acting on this? On N section. How we are going to find out? Then 20 kilonewtons. 20 kilonewtons here compression. And 30 kilonewtons here, 20 kilonewtons compression on Mn. But we want, with respect to NP, with respect to NP section, 20 kilonewtons tensile and 30 kilonewtons compression. That means it is acting how much? 30 minus 20, 10. But maximum value of direction is compression 30 kilonewtons. That's why it is compression 10 kilonewtons. So thus we have to find out the internal forces on the body which are acting on the uniform cross section. By drawing the free body diagrams, only we can know that clearly what are the forces which are acting on each section individually. When it is combined assembled portion, 40, 70, 20 and 10. When we removed tukda means disassembling each individual section, it is 40 kilonewtons on section 1 tensile, 30 kilonewtons compression or compressive load is acting on section 2 and 10 kilonewtons compression load is acting on section 3, such a way that the three sections are in equilibrium. Okay, let me summarize. In this section, we have studied how to calculate the total extension or total elongation under variable cross sections and uniform cross section. Problems are solved. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.